Question 15. The figure below shows the graph of f of x equal 1 plus e to the power of x plus 1. State the range of f of x and the asymptote. As we said before, the range related to values of y, which belongs to real or the set of real numbers. So domain related to values of x, range related to values of y. Here, values of y start from what in this graph? We can see here that values of y for this graph start from 1, because here it's the minimum value for the graph at y equal 1. But the range will be from 1 and more or from 1 and less. If the graph is drawn up, it's 1 and more, means bigger than 1. Drawn down, it will be 1 and less, smaller than 1. Here it's up, so it will be more than y. It's y bigger than 1. The asymptote. Here, this line is the asymptote, the line in which we start the range of values. But the asymptote here is y equal 1. Here the range starts from 1 or more than 1 and the asymptote at 1. But in the range we used between y and 1 the sample bigger than. In the asymptote we used between y and y the sample equals, because it's equation. Asymptote is a line and we write equation of a line. But here the range is range of values, similar to domain. It's an interval or range of values, so we'll use samples bigger than or less than. Question 16. Find the inverse f inverse of x for f of x equal ln 4x plus 12. This question we have to differentiate between the inverse and the first derivative. As we said before, the first derivative is written as f dash of x, but the inverse is f power negative 1 of x. This is differentiate and this is inverse. Here he asked to find the inverse and he already write the word inverse, but sometimes he will not write it. So we have to differentiate from the sample. First step to find the inverse is to write f of x as y. So it will be y equal ln 4x plus 12. Here, to find the inverse, simply we want to change the subject. In f of x we can see that y is the subject of the expression or the subject of the equation. To find the inverse, we'll make x the subject of the expression or the equation. Here, first step we have to get rid of ln. To get rid of ln, we'll cancel ln from this side and write e to the power in this side. We can write e power in both sides, but to simplify or to reduce steps, we'll cancel ln from here and put e power here. So the expression will be 4x plus 12 equal e to the power of y. Simply it's similar to linear equation. Move plus or minus, then multiply or divide. We'll move plus 12 to the other side. So 4x equal e to the power of y minus 12. Divide by 4, divide by 4, then x equal e to the power of y minus 12 over 4. And here, in left hand side, x will be written as f inverse of x, and we'll write the other side the same, but in the place of y we'll put x. And this is the final answer. Some students change letters from the first step. In this step they will write x equal ln 4y plus 12 and they want to make y the subject. It's the same and you will get the same answer. You will get the same answer. Question 17. F ln of x plus 2 plus ln x minus 2 equal ln 2x power 2 minus 20. Find the value of x. Find the value of x means we want to solve the equation. Here he asked to find the value of x. It's the same as if he said solve this equation. It's the same meaning. Here we have logarithmic equation or equation with ln, and we have to simplify to solve to get the value of the letter x. We'll use rules of logarithm to simplify this expression or both sides to get an equation in the letter x, and we have to solve to find the value of this letter. Left hand side we can see that it's two parts, ln of an expression plus ln of another expression. As we said before in rules of logarithm, ln plus ln equal ln of multiply. Ln plus ln equal ln of multiply. So here left hand side we can write it as x plus 2 multiply x minus 2 equal to ln 2x power 2 minus 20. Here we have two sides, ln of an expression equal ln of another expression. One ln in left hand side and one ln in right hand side. Ln of an expression equal ln of another expression. It means that the first expression equal the second expression. So here we got quadratic equation in the variable x. By solving it using any method of solving quadratic equations, we can get its value. Simplify brackets and collect like term, make one side equal 0 to get the equation in the standard form and solve. By expanding these two brackets in left hand side, you will get x to the power of 2 minus 4 equal 2x to the power of 2 minus 20. Here by collecting x power 2 in one side and numbers in one side, you will get x power 2 here and negative 20 here. So it will be x to the power of 2 to x power 2 minus x power 2 equal x power 2. Here negative 4 plus 20 equal 13. Here x power 2 plus equals 13. To get the value of x, we have to get square root for both sides. Square root of x power 2 equal x, and we'll take the square root for the other side, which is 16. But here there is an important point. Don't forget in square root to put positive and negative. We got a question before in which we solved an equation which was power 3. We took cubic root for both sides. In cubic root we don't write positive and negative because we have only one value, but here it's square root, we have to write positive and negative because we will get two values. So x equal positive 4 or x equal negative 4, and this is the final answer. But what is the difference between the solution of this equation and the values which are accepted to be values for x in this expression? Here we have logarithmic equation and we get values of x by solving quadratic equations. Positive 4 and negative 4 are the solutions of the quadratic equation, but which one of them is accepted to be value of x in this equation? This is the question. Not all values for x can be accepted to be values of x in logarithmic equation. If we substitute, you will see that x equal negative 4 is not accepted. Why? Not because it's negative, because if we put it in the place of x in any part, you will get a negative value. If we put it here negative 4, it will be negative 4 minus 2 equal negative 6.
no len for negative number, so this one refused. So we refuse the value of x, not the negative value of x. No, the value of x, whatever it's positive or negative, but this value makes the value of the expression with len negative. Because sometimes we will get expression like this: x equal len of x minus 5, like this. And we got value x equal 3. Here the value of x is positive, but it's accepted to be put it here? No, because if we put it at 3 minus 5 len negative 2, refused. So here don't refuse the negative value for x direct. You have to substitute by each value of x. The value which makes the expression with len negative is refused. Question 18. If f of x equal e to the power 11x minus 3x to the power of 3 plus 6x to the power of 2 plus 12x minus 21, find f dash of x. Here we want to find the first derivative of this function. In this question you have to pay attention, it's first derivative or the second derivative or the inverse. And as we said before, what he gives and what he asks. If he gives the function and he asks to find the first derivative, we'll differentiate one time. If he gives the first derivative and he wants to find second derivative, we'll differentiate one time. If he gives the function and he asks to find second derivative, we will differentiate 2 times. So we have to pay attention in this question. To differentiate this expression, we can see that this expression consists of some parts between all of them plus or minus. No multiplier divided. So simply we will differentiate each part separate. The first part, the second part, third part, fourth part, fifth part, and write answers beside each other. We will differentiate each part according to its type or according to its form. E to the power of 11x exponential, will write the same function multiply differentiation of the power. Second part, negative 3x to the power of 3, here it's direct multiply by the power, subtract 1 from the power. 3 multiply negative 3, it's negative 9. X to the power 3 minus 1 equal 2. Plus 6x to the power 2, it's the same, multiply by the power, subtract 1 from the power. 2 multiply positive 6, it's positive 12. X to the power 2 minus 1 equal 1. Plus 12x, we said before, any term with the variable power 1, just cancel the variable to find its derivative. So here cancel x, it will be plus 12. The last term, negative 21, its differentiation equals 0 because it's constant term or absolute term. Constant or absolute term not means it's a number. No, we can get a term with letters but it's constant, or absolute term, its differentiation equals 0. When the differentiation of the term equals 0, not when it's only number without letters. No, when there is no variable in this term. The variable here in this equation or this expression is x. Any term without x or y, here f of x is equal y. F of x can be written as y. So any term without the variable x or y, its differentiation equal 0. So this is the final answer. We can modify it by writing 11 e power 11x minus 9x to the power of 2 plus 12x plus 12.